Hello students, today we're going to talk about using graphs to relate two quantities. The purpose here is to interpret a graph that represents the changing relationship between two variables. Remember, a graph tells a story. The essential understanding that we're looking for you to get is that you can use graphs to visually represent the relationship between two variable quantities as they both change. Okay, turn to the next page. In problem 1, we're analyzing the following graph. The graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? And then describe how the variables are related at various points on the graph. Okay, what are the variables? When we talk about variables, let's think about what the word variable means. A variable is something that can change. We're looking at variables, we think of them as x and y. Okay, well, x and y are just quantities that could change. We could plug numbers in for them. When we're talking about this graph, the variables that are a part of this situation are time. Time is changing. Time is increasing along the x-axis. The other variable is the volume in the balloon. The volume of the balloon is increasing as you go up the y-axis. And just as a review, y is the vertical and x is the horizontal axis. We always put, or most of the time, we put time on the horizontal axis because it helps us to see the graph as more of a story. So take a moment and write down the two variables, time on the x-axis and volume of air in the balloon is on the y-axis. Describe how the variables are related at various points on the graph. Okay, I'm going to help you with this one. How can we analyze this graph? First thing you always do is start off, read the title. Okay, this whole graph has to do about the air in a balloon. And then the next thing you do is you look at the axes. As time is increasing, volume is increasing. So let's think about what this line actually means. The graph itself represents what happens to both of these variables as they both change. So I'm pretty sure everyone in this room has blown up a balloon. Okay, how do you blow up a balloon? You have to breathe in, and then you have to blow the air into the balloon. Okay, so think about this. Time is going on. You start by blowing into the balloon, and the volume increases and time increases in this part. So this is where you are blowing into the balloon. Now, what do you think this level part is? Here. This actually is a time when time is going forward, but the volume of the balloon is not increasing. Well, you're holding the balloon closed as you take a breath. Time is still going forward, but the volume of the balloon does not increase because you're not blowing any more air in it. So what happens at this part? This is you blowing into the balloon again, and this is you taking another breath. Blowing into the balloon again, and here's that level part where the volume isn't increasing and you're taking another breath. And then you blow a little bit more into the balloon, and what happens here? The volume goes from the highest point that it was all the way back down to, this is a volume of 0. What do you think happened when the volume was at 0? If you guessed the balloon popped, you're correct. So there it is, pop, volume of 0. Okay, try this. What are the variables in each graph? Describe how the variables are related at various points on the graph. Remember the steps. Read the title first. Think about what that means. And then look at what is on the x and the y-axis. In this case, time is increasing, but the length of this board What is happening here? That's up to you to write. In the number or letter B, it's about June's cell phone cost. And what's happening here? Pause the video and just write down the variables and what you think is happening on each side of the middle line. Turn the video back on when you're finished. Okay, hopefully you were able to write down the variables for each of these graphs in A and B. In A, your variables should be time and the length of the board. As time increases, the board length is also decreasing, and except at these places, okay? At these flat points, the board length is staying constant. So what do you think these step-looking sharp decreases are? Well, this is actually, looks like a saw is cutting the board at that particular time. And at that exact moment, the board length abruptly goes down to this level. So it's constant until the next cut. Okay? So that's what I wrote. At certain times, the board is cut and gets shorter each time. June's cell phone cost. Of course, the minutes of calls is on the x-axis, and the cost is on the y-axis. As minutes increase, the cost increases, but only from this point on. So it seems like the cost is the same. Maybe it's one of those plans where you get 100 minutes, let's just guess, and then you're charged for each minute after that at a constant rate. That's kind of seems what it is. So cost is the same up to whatever this point is, and we don't need the numbers, we just need to understand the relationship. After this certain point is reached in number of minutes, the cost then increases at, it looks like, a constant rate. Okay? Okay. All right. Matching a table and a graph. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. You can see the table here. Which graph could represent the data shown in the table? Okay, first thing is all relationships can be represented both in a table and in a graph. Our job is to figure out which graph goes with the table. Well, what we can do is look at the table and just get a general idea about what's happening. It looks like from day 1 to 2, it goes up by, what, about 600 or so, okay? And from day 2 to 3, it goes from 1,000 to 3,455, so it's like jumping up like 3 times. And then from day 3 to 4, it looks like it increases by a multiple again. So when we think about something going up at a constant rate, that would mean it would have to increase by the exact same amount every day. This isn't. This one's increasing by roughly 600 or 700. This one's increasing by more than 2,000. This one's increasing by, you guess it, less than 7,000. So that's a big difference between each. So now let's go over here and look at the graphs. In letter A, what's happening? Every day it goes up, and it looks like it goes up. If you look at the distance between these and you look at the fact that it's a straight line, it looks like it goes up the same amount every day. In letter B, it looks like it goes up one amount day 1. On day 2, it looks like it rises a little bit faster, and on day 3, it rises even faster. On day 4, it rises the fastest of all. Letter C. Letter C looks like it goes up constantly, and then it gets a little slower, and then it looks like it levels off. Definitely can't be C, because it does not level off. It keeps getting greater and greater. in letter D, sorry, it goes down from day to day. So it seems to me it has to be A or B. You go ahead and choose which one and circle that and write your explanation why in this space. If you chose letter B, you're correct. Since the amount in between each day got larger and larger, what I've done is I have found the actual amount of increase by using a calculator. And you can see from day 1 to day 2, we increased by 665. From day 2 to day 3, we increased by 2,444. And on day 3 to 4, it was 6,971. Okay, before we estimated these are the real numbers. And you can see that the amount of increase went up a great deal from day to day. The reason that it's not letter A is because the amount of increase from day to day, if you look at this slant, that is showing that the amount of increase is exactly the same. In this example, the slant is steeper each time, showing that the increased amount per day goes up at a faster rate. That's why we pick B. Okay, try this on your own. A table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So it's the number of uses versus, sometimes we say, the amount of sunscreen. So what happens to the amount of sunscreen every time we use it? What happens to the amount in the can each time we use it? Look at the graph, analyze the table for how much it actually goes either up or down each day. Answer the questions below. Bring this to the teacher station. Great work, students.